In today's video, I will explain the principles for achieving a perfectly smooth camera in Unity. Rule number 1. The player movement needs to happen before the camera movement. So, player movements happen inside update, while camera movements happen inside late update. Rule number 2. Use Lerp to move the camera. You see how smooth the camera is here when I'm jumping? That's because of Lerp. Usually this is where a lot of video games fail. Rule number 3. Don't make the camera too fast. Lerp is great, but if the camera is too fast, you're not gonna see any of the smoothness. Now yes, this will cause the camera to lag a little bit behind the player, but if you just give the camera 90 to 95% of the player's speed, it won't really be noticeable. That's what I do in Balkadia, and I've never had anyone tell me that the camera lags too much. The final rule is to enable VSync, so go to Project Settings, Quality, and select every V blank. This just makes the entire application much more stable. And that's it guys, these are the rules for smoothness in Unity. Now let me show you the example script. As you can see, it's a short script. The main idea is that the camera will follow an object called player, but there are also going to be objects that have their own box colliders, which the camera will not go outside of. So this should work well for Metroidvanias as well as top-down Zelda games. But first I need to list some prerequisites. You need one object called player. This is what the camera will follow. You need at least one object tagged as boundary with its own box collider 2D. Make sure the rotation is 0 and the scale is 1. You will use box collider size to scale the boundary. You also need a camera, which is orthographic and which has a box collider 2D. And you need to create a script called calculate camera box from my previous tutorial. I'll have it linked below in the description. If you haven't watched that video, it teaches you how to make this script. We need this script because it makes the box collider fit into the exact shape of the camera. These were the prerequisites. Now it's time for the camera follow script, which is today's video topic. So put it on the camera and let's take a look at the variables at the top. This is for the player's position. This is for the box collider of the camera. This is an array of objects for finding the boundaries. This is an array of box collider bounds for all of the objects we find. And this is going to be the particular boundary that the player is located in. Then we have a public float for the camera speed. And finally we have this equal to 0.5. I'll explain that later. So just pause the video right here and type all of these out. Now we're gonna create 3 methods. Find limits, set one limit, and follow player. Find limits is going to find all of the boundaries. So first we find all game objects with the tag of boundary. Make sure all the boundaries have this tag. Second, we give this array the same length as the above one. Then we use a for loop to get all of the box collider bounds from each of the found objects. So just pause the video right here and type this out. Set one limit is going to locate in which boundary the player is. So we go through all of the bounds with another for loop, and then over here check if the player is inside any of the boundaries. If so, we make target bounds equal to that specific boundary. Finally, we type return to stop the method, because once we find the player, there's no reason to check the rest of the array. So just pause the video right here and type this out. Follow player will use Lerp to move the camera and use target bounds to limit the camera. The idea is this: the camera's maximum horizontal position should be the boundary's max x minus half of the camera width. The camera's minimum horizontal position should be the boundary's minimum x plus half of the camera width. And the same logic applies for the vertical movement. So this is how this looks. We use matf clam to target the player, but we also set the minimum and maximum position of the camera. Same applies to the vertical position. Now, we only want this to happen if the camera is smaller than the boundary, which I've written here as a condition. Otherwise, the camera needs to be in the center. If you're not familiar with programming, this may look a little weird to you, but that's what that does. After we have the X and Y targets, we declare a vector 3 called target, which uses X and Y target and transform position.z, because we don't want to move the camera with Z. Finally, we use Lerp to move the camera to the new target vector with speed multiplied by time delta time. So just pause the video right here and type this out. Now, in the start function, we type this, and then we call find limits. In late update, we first count half a second, and then we call set one limit and follow player. Why do we count half a second? Well, for some reason something weird happens in the beginning and it just makes the camera move a little too extreme. So just wait for half a second and everything will be fine. Now let me show you just how smooth this camera is. Even when I move the player with my mouse, which is a horrible thing to do, even when I do it super aggressively, the camera still handles everything smoothly. If you want the camera not to move at all, you just need to make the boundary smaller or equal to the camera size. Or you could set it up like this, so the camera only moves horizontally. Or like this, so it only moves vertically. This concludes today's tutorial. Tomorrow at 7 AM I will upload a new tutorial about how to enable and disable objects with the camera. This is a very important topic, so if you don't want to miss that video, subscribe to the channel, hit the bell and select all. If you found this video helpful and you want to show some support, please check out Balkadia on Steam. The game is still in development, but it now has a playable demo, so if it's something you enjoy, please wishlist my game.